We're looking at sample exercise 1.7 on page 24 of the textbook. This helps us understand how to perform calculations with units and significant figures. In the first one, we are asked to calculate the volume of a box. In order to calculate the volume of the box, we need to know the formula for that, and the formula is that the volume of the box is going to be equal to basically the length of the three sides multiplied together. So length times the width times the height. And if this was a cube, all three would be the same length, so you could just take the length of one side cubed. Okay, so now we're going to go ahead and plug in the numbers that we know. So volume is going to be equal to 15.5 centimeters multiplied by 27.3 centimeters multiplied by 5.4 centimeters. Now if you pay attention to what we're doing with the units here, centimeters times centimeters times centimeters gives us cubic centimeters, so that will be the unit when we solve this problem. So if you go ahead and type those numbers into your calculator, you are going to get an answer for volume 2285.01, and again that's units of cubic centimeters, centimeters cubed. Then we need to go back and double check the significant figures on here. When you're doing multiplication problems, the number of significant figures in your answer is the same as the number with the smallest number of significant figures. So 15.5 has 3 significant figures, 27.3 also has 3 significant figures, but 5.4 only has 2 significant figures, which means that our answer can only have 2 significant figures. So what I like to do to figure that out is I like to underline the two numbers that I know I'm going to keep and see if I need to do any rounding. So I know I'm going to keep the 2 there for the 2000 and then the 200, but if I look to the right, I see an 8, which means I'm going to need to round that up. So if I round this to if I round this to 2 significant figures, I will get that volume is 2300 cubic centimeters, because this number only has 2 significant figures, and it makes sense to round 2,285 up to 2,300. We wouldn't round it down to 2,200. You don't just truncate the numbers off the end, you see if they round up or down. To be even more clear about this answer, it may be helpful to write it in scientific notation. And if we write it in scientific notation, it would be 2.3 times 10 to the 3 cubic centimeters, and again, you can very clearly see that there are 2 significant figures in this answer. Go ahead and do something similar for the next problem. We are asked to calculate average speed in meters per second, so that's going to look like m over s, and since they give us values of meters and seconds, we just need to set up this problem so that our speed is equal to the result of the 100.00 meters that this sprinter can cover over the 10.5 seconds it takes her to cover those. Now if you put this into your calculator, you are going to get a very long, very ugly number. And again, units of meters per second. Now we have to remember that calculators only do what you tell them to, and that's why the calculator did the division problem. It is our responsibility to figure out the correct number of significant figures. Since this is a division problem, it follows the same rules as multiplication problems, which means that the number of significant figures in our answer needs to be the same as the number we did the math with that had the least number of significant figures. 100.00 has 5 significant figures, but 10.5 only has 3 significant figures. Since the smallest number of significant figures is 3, that means our answer can only have 3 significant figures, so I know I'm keeping the 9, the 5, and the 2. And if I look to the right of the 2, I can see the number 3. I'm going to round that down, not up as in the previous problem, so that means our speed rounded to 3 significant figures is 9.52 meters per second.